right, number 18 is really similar to number 17, but we're going to actually graph this one on paper and pick out a couple key features of the graph. So for starters, we're given the function f of x is equal to 2 ln x plus 3 minus 2. And we're asked to first find transformations. So this 2 out front is going to be a vertical stretch by 2. Plus 3 on the inside is going to move it left 3. And minus 2 at the end is going to move it down 2. So now we're going to go ahead and graph it in the calculator. And so in y equals, type in your original equation. Go ahead and hit graph. And see if there's any key points you can find on this. So I'm going to start by going to the table. And to see what we can find, oh, there's one. -2, -2. And I'm just going to go ahead and snap this over. Alright, so I'm going to graph -2, -2. And then it doesn't really look like there's a whole lot of other nice points, but I'm going to put another point on there just to kind of help me, or a couple extra points. So at 0, it's 0.19. That's our y-intercept. So it's just like right there. At 3, it's at 1.5-ish. So I'll plot that point. And 6, it's a little bit higher than 2. So I'm going to plot those couple points, go back and look at the picture, and just make sure my graph looks pretty similar. Alright, so it looks like there's going to be an asymptote here at -3. We'll confirm that here in a minute. So I'm going to go ahead and draw that in as well. So I'm going to put in this vertical asymptote at -3, and I'm going to color coordinate it because I can. Alright, so we have our graph of natural log, and it's going to go through these points, and then it's going to turn and kind of right along this vertical asymptote. So since we're just talking about this graph in particular, I'm going to go ahead and move down to part E, where it asks about the domain, range, asymptote, and then the intercepts. So the domain of this, you can go back to your original equation, take that x plus 3, and set it greater than 0. So when you solve it, your x is greater than -3, which our graph visually confirms for us. Wherever your domain has to be greater than, that's when your vertical asymptote is going to occur. Which is, again, what our graph looks like. The range here, it's going to go down forever and it's going to go up forever. So your range, you could say all real numbers, or if you wanted to write it in interval notation, -infinity to infinity. Your y-intercept, let's go back to our table. The y-intercept you should be able to find in your table. It's wherever 0 is in the x column. So 0, 0.1972. Alright, and then the x-intercept, that one's not going to be in our table. However, we can utilize the calculator to find it for us. So for those of you with the TI-84 calculators, you can hit second, trace, and option 2, 0. It's going to ask you left bound and right bound. So there's my left. I'm going to go to the right of the x-intercept, hit enter, and I'm not going to move it to guess. And it looks like our x-intercept's at -0.2817. And 0. Alright, you'll see why I had you find those in just a second. Because now we're going to go ahead and find the inverse. So I'm going to do this one in green. Alright, so we want to find the inverse. So I'm going to start by rewriting 2 ln x plus 3 minus 2 equal to y. And then your first step after that is going to be to switch the x to the y. And because I don't have a lot of space, I'm just going to write in purple over top of that x, turn that into a y, and now all of a sudden that y is an x. So from here, we're going to have to get rid of that 2 first, by adding 2 to both sides. So we have 2 ln y plus 3 is equal to x plus 2. Before we can do anything with that log, we have to get rid of the 2 out front. So we have ln y plus 3 is equal to x plus 2 over 2. And if you want to split that up to make it x over 2 plus 2 over 2, or x over 2 plus 1, you can, and I'll show that in the answer here in a second. But now comes the time where we have to use this exponential relationship. E raised to that is going to equal this. So E raised to the x plus 2 over 2 is going to equal y plus 3. Subtract the 3, and we got our inverse. E to the x plus 2 over 2 minus 3 equals y. And what I was saying earlier about splitting it up, you could also say e to the x over 2 plus 1 minus 3 is equal to y. That's an equivalent way to write that. And basically it's just taking these, doing x over 2 and 2 over 2, which just ends up being 1. So it's up to you. Doesn't matter to us. But at least as you recognize that they're both the same thing, that's the one I'm going to go with. Alright, so before I do anything else, I'm going to go ahead and graph that equation to make sure that it looks like it's supposed to. So e to the x over 2 plus 1. E raised to the x over 2 plus 1, and then minus 3. And I'm going to go ahead and graph it. Alright, so I'm going to check my table. So we had the point -2, -2 on our original, and if you take and reverse that ordered pair, it would still give you -2, -2. So the fact that this is on our inverse is a good sign. It should be. And then maybe we kind of pick out a couple extra points to graph. It looks like this, if I go back this direction, notice how these numbers are getting closer and closer to -3, and eventually it actually gives us -3. That's where our horizontal asymptote is. So I'm going to pull this over here for a second, make it easier to graph. Alright, so we've got the point -2, -2, which is going to overlap our original graph. Let's see here. 0, -2.82. That's going to be down here. 1's like 1.4. 2 is at 4.3. And it's supposed to level out at -3 this way. So let's go ahead and connect them. Alright, so it's going to level out here, hit this point, and go on up. Okay. So there's a lot going on that graph. We'll come back and finish it up here in a second. Change the color of this. Don't want it so fluorescent. That's better. Okay. So if we're looking at this green graph now, and the asymptote that goes with it, your domain, it goes forever to the left and forever to the right, so your domain would be all reals. Your range, it's only going to go down to -3 and going to go up forever, so it's not going to equal -3, so it's just going to be y is greater than -3. We have an asymptote at y equals -3, so that horizontal asymptote that we talked about. Then your x and y intercept, if you go back to your graph, or your table rather, here is your y-intercept, 0, -2.82. of 0 and negative 0.2.82. And then the x-intercept, we're going to have to go and have the calculator find that for us. So go back to the graph. Second, trace number 2. And again, left and right bound. Okay, so 0.1972. Okay. We'll come back and talk about that in a second. But I was supposed to label these graphs, and I didn't. So I'm going to go ahead and do that now. So if you remember, the green graph is our inverse. So this is f inverse of x. Our blue graph is our original. So this is f of x. And then we can go ahead and draw in the line y equals x. And notice as I do this, what should happen if I did a good graph is that if the two graphs overlap each other, with this, in this case they do twice, the line y equals x should overlap them as well. So it looks like my graph looks pretty good on the left, could be better on the right, but I tried. So this would be y equals x. And what you could do also is in your calculator, if you go back in here, I turned that original function off. And so I'm going to go back and turn that back on and add in the line y equals x. So I'm going to see all three of those that are graphed on paper together in the calculator. And that's what it should look like. And again, this blue graph's getting cut off because your calculator has a hard time graphing vertical lines. But yeah. Okay, the last thing I want to talk to you about is this whole business at the bottom. Alright, so the reason why I set it up like this is because I want you to check when you talk about inverses of something, x and y switch position, and everything about x and y are going to switch position. So the domain turns into the range. So the x values turn into the y values of your inverse. So those should be the same, but with different variables. Your range becomes your domain. Again, both are all reals. For the asymptotes, notice how one of them was x equal, and the inverse is y equals. And then for your intercepts, your y-intercept, notice how we have the same digits here for our x-intercept, and the same thing's happening here with the y-intercept. The only difference is here we have more digits, and in our table it only spit out 3 digits after the decimal, but if you round this to the nearest thousandth, it would be 2.82 as well. So doing all of this stuff at the end is a great way to check your work, as long as you know the relationship between the two.